So we'll continue section 6.3 and we'll talk about how to solve these equations and inequalities, but this time we'll do it using a computer-generated graph or a calculator-generated graph. And you can see I've got my Desmos up and running here. So that's what we'll use. So in the first two, we'll work on them together with really the same graph. You'll notice it's the same fractions here. Just once I want to solve the equation, and then over here I want to solve the inequality. In both cases, I find it easier to work with if I have 0 on one side. So I'm just going to go ahead and move everything to the left. Equals 0 for part A. And less than or equal to 0 for part B. So I'd like to go ahead and I'm going to graph the left-hand side on Desmos, and then we'll see what we can use on the graph to help us solve. So I'm graphing 6x squared over x squared plus 4 subtract 3x over x minus 1. And if my only question is where is that equal to 0, as in part A, I can see that I get that equal to 0 at those three x-intercepts. So I would have x equals approximately negative 1.236, x equals 0, and x equals 3.236. And that's all I would need for my equality. All right, for the inequality, I've already got the graph done, but I'd like to know where this is less than or equal to 0. So let's take another look at the graph. I can see that down here, my y values would be negative, or less than or equal to 0. So that would be from negative 1.236, comma, 0. And then the graph becomes positive for a while, but then right here at the asymptote, it becomes negative again. We have to think about where that asymptote would be. If I go back to my function, notice that at x equals 1, that denominator would be 0. I'm going to go ahead and put x equals 1 in as a dotted line to show that it's an asymptote. And so what I can now see is that the graph becomes negative again right after that vertical asymptote. So from x equals 1 to x equals 3.236. I'll only be able to use a parenthesis at the 1 because the graph doesn't actually touch it. It's an asymptote. But I will be able to use a bracket at the 3.236. So this is what my solution looked like. I had brackets at both the negative 1.236 and the 0 that covered this little piece that was definitely less than or equal to 0. And then I had a parenthesis at the 1, that was the asymptote, and then it stayed below 0 until the 3.236. And that covered this little section down here. All right, let's try another one. Again, I've got two similar or two related problems. I've got an equation, and then I've got an inequality. And once again, I would prefer to have 0 on one side. So let me write that right away. I'm going to subtract the x and add the 2 to get that equal to 0. And similarly with the inequality, subtract the x, add the 2 to get that greater than or equal to 0. I was a little behind the times in the last one. I probably should have written this out first. We did it on Desmos, but notice we saw x can't equal 1 here. Let's talk about that first before I start graphing. Here, it's the x squared minus 9 that can't equal 0. So x can't be 3 or negative 3. Right? Those would be my vertical asymptotes. And as we saw, those can be pretty important. So when I graph, I might want to put those in. All right, so let's graph. Two x squared over x squared minus 9 minus x plus 2. All right. And let's see, I can just put that, it doesn't really matter, but I usually put in something like y equals or f of x equals, so I'm going to do that. I had my asymptotes, x equals 3 and x equals negative 3. So there are those. And right now, I feel like I'm missing something, right? I have a section on this side of the asymptote. I have a section on that side. But I don't see the section over here to the left of that first asymptote. So I'm thinking maybe I should go ahead and, there we go, change my y-axis till I see where it is, right? I didn't know if it was up there or down here. I need to see it to know where it is. Now I feel pretty comfortable that I'm seeing enough of the graph that I can answer the questions. So first of all, where is this equal to 0? 3 places. I would have x equals negative 2.496, x equals 1.421, and x equals 5.075. And that's going to take care of the equation. That's all I need. All right, the inequality this time was greater than or equal to 0. So let's think about that one. Certainly this whole first section is above 0. And that section would go from negative infinity to negative 3 with a parenthesis, since it's an asymptote. So my first interval goes from negative infinity to negative 3. Between these two zeros, my graph is above 0 again, greater than 0. And those are just zeros of the function, so I can include those with brackets. From negative 2.496 to 1.421 with brackets. Then, to the right side of the asymptote, once again we're above 0 until we get there. So starting at the asymptote, x equals 3 with a parenthesis, until I get to 5.075 with a bracket. And there's what my solution looks like. All right, so that gives us our technology methods for solving rational equations and inequalities, and brings us to the end of section 6.3.